Hey everybody, in today's video we'll be looking at problem 23, merge k sorted lists. You're given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. Look at example 1. We have a list 145, 13426. We can see the k is 3 because there's 3 linked lists in here. Ascending order, each one, and then the output is another linked list in ascending order made up of all these items. Example 2 is very simple. An empty list returns empty as well. This is a little trickier. There's a one empty list within lists, but it should also return an empty list. So looking at the constraints, k is list length. We know that, and then k is between 0 and 10 to the power 4. 0 is less than or equal to each list is between 0 and 500. Each value of node is between negative 10 to the power 4 and 10 to the power 4. And each list is sorted in ascending order. We see that here, 145, 134, 26. And the sum of each list will not exceed 10 to the power 4. So let's just look at this first example. So if you were to think about this in a very manual kind of way, what you would probably do is just look at the first 3 items. You look at the first item of each list and just grab which is smaller and just put it in the new list. So now it's 1. So we grab that guy. We grab 2. Now we grab 3. Now we grab 2 4s. Now we grab 5. Now we grab 6. And that's all there is to it. That gives you the final answer. So how do you implement this? So the two main ways of thinking are, and they're not mutually exclusive obviously, but there's heaps and there's priority queues. So heap is a data structure where you represent the array as a binary tree, and I'll create a new example for this guy. So you can just grab all the root of each of these linked lists to 112, put them into a heap, and then heap, the 1 will be the root node because it's the smallest. You just grab it, put it into your new array, and then keep heapifying until you've gone through the whole array and you have your final result. Priority queues are it's a way of storing arrays where storing an array where each time you add an item, it has to be put in the correct spot. So minimum priority queue will put the smallest numbers at the beginning, and then larger numbers towards the back. So it essentially becomes sorted. So and priority queues can also internally use a heap. For our case, because we'll be implementing this in JavaScript, we won't put a heap in the priority queue, but definitely know that if you wanted to do that, you definitely can. So let's just build out a priority queue. What are the pieces? So you have a constructor, nothing to do there. We have our items. We have an onQueue method where you're going to pass into it, and you have a dqueue. So onQueue is adding an item to the priority queue. Dqueue is removing the first item because it's a min priority queue, removing the first item, which will be the smallest. So you can say return this.items.shift. So shift will both give you the smallest number and remove it from this items. It'll also be useful to have has next in case this item is empty, in which case dqueue wouldn't really do anything of use. And okay, I guess we got to implement the harder part. So if you imagine you had 1, 2 in our items, so items equals 1, 2, and we're trying to add 3. We have to add it to the end. So, but then if you were adding 1.5, it would be right in the middle. So this idea, we call it contained, equals true equals false. And then if it's not contained, so this would be if it's 3. If it's not within this array, then we just push value. Now we gotta see if it is contained, if it fits within. I'll add a 4 in there, or 5. See, now it would be contained. So let I equals 0, I is less than this items of length, I plus plus, if value is less than this items I, then contained equals true. We found its spot. We can splice it in, and with the value, and then we're done. We can move forth with our lives, and new priority queue. What else can we do? No, let's see how that guy does with, if it's empty, maybe return empty. I guess the next case is this. This guy's kind of annoying. So the way we're gonna just, in our example, was we have to like just keep iterating until we're done, and while loop is the way to go. Always the length. So let's try to solve for this case first. This is a simpler case. For let I equals 0, I is less than length, I plus plus. If there's no list I, so just empty, then we want to do special stuff. Because we want to track is empty, it's false. So in this case, is empty equals true. What else can we do? We need to get rid of it because we want the list array to be empty in order to break out of the while loop. So we can just splice this guy out. This linked list is of no use to us anymore. What else can we do? I guess break. No need to keep iterating here. And then I guess if it's empty, continue, because so I think this, let's see how this does with this case. Okay, so we were able to break out of the loop and return empty array, but now we've got to deal with the more complicated case. So we need to start constructing a new node. Like cur. So cur will be iterating to keep building the next statements. So if there's no new node, so this is a completely new linked list, we need to set up its head. Then and then we need to first add to our priority queue, pq.enqueue list I.val, and then we want to move it to the next node. List I.next. So there's no new node, then new node equals pq.dequeue, and cur is new node. But now if there is a new node, that means that we're already in the process. So we can say cur.next equals, and we need to make this a list node. New list node. And just keep moving cur to the next spot. And so new node will be our head, so we can return that instead. Let's first make sure that previous examples still work. Okay, they still work. Now let's see how this guy does. Okay, so It didn't give the right answer, but we do start to see we have 1 and 1. So what happened here was we need to, like, our priority queue still has more items. So we can just go ahead and just keep adding to our cur until our priority queue is empty. So while pq.hasNext cur.next equals pq.dequeue, and then cur equals cur.next. Let's see how that guy does. Oh, my bad. New list node. Okay, so that one passed. Let's see how we did. So there you have it. That is one approach to solving merge case ordered lists. So thank you, and catch you later.